So with this circuit, I am getting a ding dong ish sound when I press the button. But now the problem is when you release the button, the doorbell doesn't stop ringing. So I did some more troubleshooting and go to the bottom of the issue. I think I found the culprit. You see this red wire here is connecting to the positive rail and then goes all the way to our reset pin. So in other words, it's keeping our reset pin high and preventing it from going low when we release the button. I'm pretty sure this is where our problem is coming from, and I don't even remember putting this wire here. I don't even know how it got there. Okay, so here we go. Nice. That was our first major success, and a much welcomed one at that. With this success, I decided to take the project to the next stage. Now, because I intend to use this doorbell in real life, I can't do that whilst it's on a breadboard. For starters, the sheer size of the breadboard will make the doorbell bigger than it's actually necessary for it to be. And also having a device with all those loose connections in there is just creating a lot of room for things to go wrong. So I'm not going to go and design a PCB and then I'll show you what those designs look like.
Several days later.
So I finished designing the PCB and here's a 3D rendering of what it might look like. I'm going to take this PCB design to the workshop and we'll see how it will come out.
Several days later.
So the plan was to do a simple single-sided PCB, but then I thought maybe I'll try doing very thin traces. This is my attempt on 0.2 millimeter traces, and as you could see, for the most part everything was okay except for 3 areas. So we have these 2 thick areas, which are areas that I identified before the etching process, and I managed to do a simple quick fix. And then there's this part which is a trace that's broken. Sorry. Okay, so here we go. I think you can see it much clearly now. So I got a broken trace here, but then other than that, everything else is fine. The thing is, with these thin traces, depending on the equipment we have, the process requires a lot of precision work and attention to detail. I won't recommend them for DIY projects, but then one advantage of having thin traces is that they allow you to have this kind of connections, you know, like fitting a bunch of connections in as little space as possible. That will help you save on the board material, you know, because the larger the board you use, it also translates to the cost of the overall project. With that out of the way, I proceeded with the PCB fabrication process. So this is what our PCB looks like. It's not perfect, but I'm sure it will get the job done. So a few things that you'll notice is that I did the repair for the broken trace here after putting the soldering mask on, and then on the other side the silkscreen wasn't perfect. I think you notice a bit of smudging right around this area, and some of the lines are not clear than the smudging, and then also the general alignment. You see this box was supposed to be in between these through holes, same with the capacitor holes and the capacitor markings. But all in all, I think it will work. So now I'm going to go off screen to solder the components and then we can test the board together. So I'm done with the soldering and it looks a bit better, I guess, with the components soldered on. While the soldered PCB came out much better than expected, little did I know that it had a little surprise in store for me. So let us now proceed to press our button. Luckily, the problem was not that difficult to find this time around. Now, I don't know if you can see this, but there seems to be signs of damage on this capacitor. So I'm going to try and replace it and see if we can get our original ding-dong sound. So after many setbacks, we finally managed to get that classic doorbell sound. or at least as close to it as we could possibly get with the components at our disposal. But nonetheless, I was satisfied.